Okay guys, so
Entertainment.
let's go ahead and solve this triangle. So like I said, this section is going to be quite a bit of a review. So all things we've kind of talked about already. There's not a lot of new stuff. It's just going to be like applying it to the real world. Okay? So, what, Shannon? When I give you the project on Monday.
Can I have Brady as my partner? He's smart.
You will not be with anyone you were with for the last project.
So I won't be with Brady or Blake.
Nope.
Gosh. Who was I with?
Yeah, and then you'll have when you come back.
Oh, yeah.
Why?
I forget everything. I have Shannon.
It's all like a review project, so. Okay guys, let's solve our triangle. So when it says solve, we know that that means we need to figure out all of our angles and all of our sides. So a triangle isn't solved until we have every single piece of it, okay? So based off of what we have right here, I know it's a right triangle, so I have a right angle. I have an angle of 34.2, and then I'm gonna need to figure out this angle up here. And then I have one side of 19.4. I need to figure out A and C. So let's go ahead, let's start by figuring out our other angle, because I think that's not too challenging. How would I figure out this third angle if I have one that's 90 and one that's 34.2? Yeah, because my whole triangle needs to add up to 180. So if I take 180, I subtract out the one angle of 90, subtract out my other angle of 34.2. What number is that going to give me? If you don't have your calculator, I get your calculator today. 55.8.
55.8.
Perfect.
I did a math.
Yeah. Okay, so now I have this angle is 55.8 degrees, because everything's degrees. Okay, so now because my triangle is in degrees, when we now use like sine or cosine or tangent, we need to make sure our calculator mode is in degrees. Okay, so if your mode is in radians, switch it over to degrees because we're using degrees with this triangle. Okay? So now let's go ahead, let's solve for A next. So let's use this angle of 34.2. So if I have this angle and I'm solving for A, and then I have this side, what do I want to use? Like sine, cosine, tangent? Sine. So opposite over adjacent, which is tangent. Same thing. So we're going to use tangent. Okay? So I'm using tangent because I'm using my opposite side and my adjacent side, and I'm using this original angle that they gave me. We could have used different measurements, it doesn't matter. But so if I use my tangent of my angle, so tangent of 34.2 is equal to my opposite, which is A, over my adjacent, which is the 19.4. And then I know that this is over 1. So now to solve this for A, Madison, what do you think I do? Yeah, I can cross multiply. So then I'd have A equals 19.4 times my tangent of the 34.2 degrees. So now in your calculators, go ahead and type in 19.4 times tangent of 34.2 and let me know what we get for our side length.
13.18. What?
13.2.
I got 13.182, Carter.
Yeah.
You guys got 13 point,
Yeah,
Oh,
but I
I
was
put
just
it on.
rounding.
you're rounded.
Like
Oh, yeah.
13.2.
I put it, yeah,
Oh,
13.2 round.
Yeah, 13.2, we can round up because this one has just one decimal place, so we can say 13.2. Okay. So now this triangle has a side of 13.2. Carter, how do you think I can figure out my last side?
Don't make me try to say the Pythagorean.
We could do the Pythagorean theorem. Or, yeah, we could do the Pythagorean theorem. Or, since these are decimals and not super nice numbers, could we also just do like sine or cosine and figure out my hypotenuse? Like, aren't there multiple ways I could do this? Yeah, so let's use the same angle again. So if I want to use, let's do this angle, the side we started with, so our adjacent and our hypotenuse, what should I be using? Sine, cosine, tangent, what do you think, Carter? That's okay, Alyssa said it for you. Cosine. Yeah, because we know that cosine is our adjacent over our hypotenuse. Okay, so our adjacent, so we're still using this angle that they gave us. So our cosine of our angle, so cosine of 34.2 is equal to my adjacent, which is 19.4, over my hypotenuse, which is C. Then Shannon, how would I do this? So cosine of 34,
Multiply by C,
multiply by C?
right,
Yeah,
and then divide by, or 19.4 divided by cosine of 34.
yeah, because if I multiply by C, I'd have C times cosine of 34.2 is equal to 19.4. And then Shannon said divide by the cosine of 34.2. So my C is gonna be 19.4 divided by cosine of 34.2, which when I type that in is going to be,
23.5.
yeah, 23.5 when I round that.
Three numbers. This is like all the values. That'd be nice.
Yeah, so 23.5. Okay, so there's my triangle all solved. So we found all of our sides and all of our angles. And remember guys, there's multiple ways you could do this. Like we could have done the Pythagorean theorem to find our other side. Or we could have used like this angle up here and done, or like, you don't have to pick what I just picked. I was just picking things for us. Okay, so yeah, because if I had used this angle up here, I could have done, instead of cosine, I could have done sine of opposite over hypotenuse and still use the 19.4 over C. But if I use that angle, it all solves out exactly the same way. Yeah, Carter?
Okay. So the tangent like represents the number. I was wondering, cosine and 34.2. Doesn't just equal 34.2.
Nope, it's, so I'm taking the cosine of this angle. So this is my angle, it's like written in degrees. So I'm taking the cosine of that angle, and the cosine of that angle is like a number, just like on our unit circle, like the cosine of 30 degrees is 1/2. So this is a number, but this right here is an angle.
Yeah. So cosine and sine are like are not angles, for numbers.
They are numbers, yep, so once you put an angle in them, cosine, sine, tangent, all of it is a number.
Okay.
Yep,
I just want to know that.
yeah,
It's like,
yeah, they're all numbers on our graph. They're like points on a graph. Think about like X's and Y's. They're just points on our graph. They are numbers.
how did someone figure this out?
I don't know. Okay guys, let's do like another triangle application. So we have this picture right here. I'll draw it a little bit bigger so we can see it over top of this building. Okay, so here's my triangle. So it says a point 200 feet from the base of the building. So this is 200 feet, because here's my building. So we're at a point 200 feet from the base of my building. Has an angle of elevation. So remember, elevation means you're looking up. So it's an angle going up. To the bottom of a smokestack is 35 degrees. So we have this building, and then on top of it, we have like this smokestack where the smoke's gonna come out of. So the angle from there to the top of the smokestack is gonna be 35 degrees, okay? So this is 35 degrees, okay? Because this is a building, put some windows in here, maybe a door. Okay, so here's our building, and then here's like our chimney on top of it, okay? Okay, so that's what we're looking at. Because I'm a great artist, I should teach art. Okay. So my angle of elevation from my person looking down, looking up, is 35 degrees. And it says, whereas the angle of elevation to the top, so if I look all the way to the top, it's gonna be 53 degrees. So this whole angle is 53 degrees versus just this little one is 35. So what I need to do is I need to find how tall the smokestack is. So I need to figure out this distance right here, and we can go ahead and call that X. Actually, no, to do the same variables, we'll call it S for a smokestack, and then they're gonna call this A. So let's change that.
So
now we're splitting triangles.
We are splitting triangles, and A is our distance, our height of our building.
S for small.
What?
An S for small.
Yeah, an S for smokestack.
And then,
Okay, anyone have any ideas?
Do the, on the
So,
not this one.
What?
Goes not 82 degrees to get 200, and so you also do better and clear and get
Okay,
well, you know it's a 90-degree thingy.
yeah, so if we start by, yeah, we do know it's 90 degrees. So we could now figure out our A value, our height of our building. So if I do my height of my building, I have just this triangle right here. So it has an angle of 35 degrees, a base length of 200, and then a side length of A. Yeah,
Can't you just figure out, or could you figure out S then by taking 53 degrees minus 35 degrees? To get what that little section thingy is?
to figure out my angle right here.
Yeah.
Well then, so then we'd have like this weird triangle. Then I can't use sine or cosine or tangent if I don't have a right angle. So I wouldn't have a right angle of this. If I were to take this triangle out, I wouldn't have a right triangle. So I couldn't use it anymore. Okay, so good thought though. Okay, so let's go ahead, let's try to figure out A. So if we have, here's my angle, it's 35, and then I have opposite and adjacent. So Blake, what do I want to use? Yeah. Yep, tangent. So I have tangent of my angle, which is the 35 degrees, because I'm just using the little triangle right now. So my angle's 35 degrees, is equal to my opposite, which is A, over my adjacent, which is 200. So then Blake, how would I solve this?
Cross multiply.
Okay. And what would I have?
30, or tangent of 35 times 200 is equal to A.
Yeah, exactly. Yep, so once I cross multiply that, I have the tangent of 35 times 200 is equal to A. So type that in, you guys. Make sure you're in degrees still.
140.
140? Yeah, so 140 is gonna be how tall my building is. Okay, so this is 140. Okay, so now that I know that, how can that help me figure out this up here?
So we do that.
Okay, add or subtract. So what if I think about my big triangle now? So I have an angle of 53 degrees. I have an adjacent side of 200. Could I solve for my opposite side? I know that I have 140 plus my S would give me my opposite side. So if I set this up, we could do tangent of my, so we're using the full triangle, so tangent of 53 degrees is equal to opposite over adjacent. So now my opposite side is S plus 140 because it's this whole length. So I'd have S plus 140 over 200. So now I just have one variable, so we should be able to solve for S, and that's gonna give me my height of my smokestack. Okay, so I just had to set up my triangle just like we have been doing. The only thing that was different was my opposite side was the 140 plus the S, because that's that distance. Does everyone see that?
And you use 53 degrees.
Yep, and we'll use 53 degrees because it's the full triangle. Yep, okay, so then Jasmine, go ahead and help me solve this.
Take 200 on both sides, like multiply it.
Okay.
And then we subtract 140 on both sides.
Yeah. Yep, because if I cross multiply, I have 200 times the tangent of 53 is equal to S plus 140. So then if I go ahead and subtract over the 140, I get S all by itself. So go ahead, type in 200 times tangent of 53 and then hit enter and then subtract 140. 125 point, like 4?
Wait, I got
4.
Yes.
37. You type it in wrong?
How do you do this? 200?
Yep, so,
Oh, I didn't do the times. Enter.
yep, and then hit enter, because then you're gonna subtract from this whole value, the 140 from there.
Oh, wait. Yeah,
Okay.
there we go.
How do you guys feel?
I'm so proud.
Surprisingly well.
That's good.
Surprisingly okay?
Hold on.
Okay.
Oh, that's all we had to find.
Yep, that's all we were finding. We weren't solving the whole
Never mind.
triangle.
Oh.
Never mind. We're
Madison?
This has nothing to do with this triangle, but this is just something weird I noticed. When you wrote your 53, I noticed that your first like smoke squiggle kind of looked like a 53.
Oh.
I don't know why, but
A little bit. Okay.
I see it.
You see it.
Oh, more word problems. Yay.
More work. I told you this whole section is like applications. Okay, so this time we have a swimming pool. So our swimming pool is 20 meters long. Okay, so the distance is 20 meters and then it's 12 meters wide. The bottom of the pool is slanted, which makes sense, like a shallow end and a deep end, so that the water depth is 1.3 meters at the shallow end and 4 meters at the deep end. So it says find the angle of depression. So the angle of depression is our angle going down from the bottom of the pool. Okay? What'd you say, Carter?
You said find the angle of depression, I said that's negative.
So punny. All right, so let's go ahead. So we have, this is our pool, guys. So if I'm gonna draw a triangle, this isn't quite a triangle. Well, there's kind of like two parts to our triangle. Okay, so what I'm,
where did
okay,
that come from?
okay, so where this is coming from. So when I get in my shallow end, okay, so this is the shallow end over here. And then this is my deep end over here. So when I get in the shallow end, it's not starting at like ground level. I like still hop in the water. So like here I hopped in the water and like I'm in the water. So I'm starting at like a deep.
You're sliding down that pool. You're
There's
Yeah,
no
that's-
spot to stay. You're either treading water or you're going down.
Okay, so, but we hop in our pool, and at the shallow end, we're just 1.3 meters deep. So when I hop in the pool, I'm 1.3 meters deep, okay? So that's my shallow. Then, as I walk towards the deep end,
You're sliding.
now, all of a sudden, at the deep end, I go down from the distance from where I started at the 1.3 meters, now all the way down, I'm gonna go down 2.7 more meters. So this distance is 2.7, and this distance is the 1.3. So at the shallow end, I'm 1.3 meters deep, so like 3 feet. And then as I get deeper, I'm gonna be at like 8 feet or whatever. Because we're in meters. But okay, so what would my total depth of my pool be? If I take 2.7 plus 1.3, what does that give me? 4. Yeah, so my total depth of my pool is gonna be 4 meters. So at the deep end, I'm 4 meters down, so like 12 feet. So kind of a deep pool. Okay, so what I'm trying to do is I'm trying to find this angle of depression. So where the pool starts going down, where it starts slanting down from my shallow end to my deep end, I'm trying to figure out what that angle is. Any thoughts? Do tangent, okay, I like that.
Last few times.
trying to get out of that pool.
Maybe. So you said tangent, Jasmine.
Which
What
is
if
opposite over adjacent.
Okay, which is opposite over adjacent. We know that this distance is 20 meters. So if I'm looking at this picture right here, don't I have a triangle right here?
Yeah, so it'd be 20 over 2.7.
Yeah, so 20 over 2.7, just like, well, 2.7 over 20. Opposite over adjacent.
Oh, yeah.
Yeah, so if I have this side length is 20, this depth is 2.7,
We got a right angle.
so then, and I have a right angle, if I have an opposite side and an adjacent side, I know I'm gonna use tangent. So I have tangent of my angle is equal to my opposite, so 2.7 over my adjacent, which is 20. Okay, so then if I'm trying to solve for an angle, what do I use?
Inverse.
Inverses. So go ahead and type in, because if you take like the inverse tangent of both sides if I take the inverse and the normal, they just cancel. So I have theta
I like 7 degrees.
is equal to the inverse tangent of 2.7 over 20, which, what'd you get, Carter?
I like 7.7.
Yeah, 7.7. I like that. Which is gonna be 7.7 degrees. So that pool slopes down at like 7.7 degrees. So,
Wait, how did you get that?
so we took the inverse tangent
Oh.
of 2.7 over 20.
And that's only with angles is when you
Yep, so you only use inverse when you're solving for an angle.
for the final, are we doing the prerequisite too, over the prerequisite?
Yep, everything this semester. Okay, all right, how do you guys feel on that second one? Yep, that's all we have to solve for that one. Okay, guys, let's go ahead and let's find out altitude of this isosceles triangle. So we only can use sine, cosine, and tangent when we have a right angle. Do I have a right angle with this? No, I do not have a right angle.
So,
Could I maybe make a right angle, like divide that triangle?
Yeah.
oh, you make 2 right angles.
I could divide it right down the middle, right? And then I would have right angles here and here.
Yeah.
Is everyone okay with that?
Yeah.
Yeah, because then we know how to do stuff with right triangles. Okay, so here's my triangle. If I divide it right down the middle, now I have right triangles. Okay, so these are thetas. This is my B value, so this whole thing is B.
Isn't isosceles when every side's the same?
Yeah. No, that's equilateral. Isosceles is 2 of them are the same and one's different. Okay, and then it tells me that my B value is going to be 11 feet. So this whole distance is 11, and my theta is going to be 27 degrees.
On both sides.
Yeah.
So, does that mean, you're,
And we're trying to solve for the altitude, so that's the height of my triangle. So I'm trying to solve for this distance right here.
so isn't it your, adjacent
Wait, now it's all
triangle?
You said 36 on that one side, I did one side. 36 is.
All right, sorry. Madison's trying to talk, guys.
Okay, so like, since you split your triangle, you can obviously now split the B, so you split both of them, and you split it in half, when you get 5.5.
Yeah, so if I split, since I split my triangle, I need to split that distance of my B, so half of it will be 5.5. So now, if I have this angle, this side, and this side, Madison, what would I use? Tangent, yep, because it's opposite over adjacent. So how would I set it up?
5 or tangent of 27 over equals x over 5.5.
Yeah, exactly. Yep, equals my opposite over my adjacent. Okay, and then Carter solve this one for me.
Oh, shoot, we multiply by 5.
Yeah, I can go ahead and just cross multiply. So I have 5.5 times tangent of 27 degrees is equal to x. And then if you type that in someone, what do we get?
2.8.
2.8, yep. Yep, so my altitude or my height of my triangle is gonna end up being 2.8. So if you see something like this, we can't use sine, cosine, or tangent unless we have a right angle, so we would need to make a right angle.
So.
What do you use
Everything?
No, but it didn't say solve it, it just said find the altitude. If it says solve, then you need to find everything.
I'm trying to find everything.
No,
Uh,
so most of them you won't end up finding everything. It'll just tell you something specific. Okay guys, last concept. Harmonic motion. Okay, so we're transitioning from triangles. Alright, so,
Let's go back to the triangle.
okay, so harmonic motion. What this is gonna be like sine and cosine equation, because if you think, so here we have this spring and a ball on a spring. So if you think about, I feel like we're not paying attention.
Okay, do that one.
You're okay, I was talking to other people too, Madison. Okay, so if you think about a ball on a spring, so the spring can go like out, like up and down, right? So if it's over time, wouldn't it kind of look like a sine and cosine curve? Because here's my ball going up and down like a sine or cosine curve. Does that, everyone in your mind, you see that, how that could look like that? So harmonic motion is something that like models that. So we're gonna use sine and cosine. And it's just talking about like a pendulum, like the motion of it just back and forth, and it can keep going on and on forever. Okay, so with our picture right here, it says a ball is bobbing up and down on the end of a spring. So 10 centimeters is the maximum distance that the ball moves vertically. So when it talks about the maximum distance, that's gonna be the amplitude, because that's how high up you could go on your graph and how high down. So whenever you're talking about your maximum distance, that's gonna be your amplitude, okay? And it says that it moves vertically up or downward from its equilibrium or its at rest position. So like where the ball is just like at rest. The spring isn't stretched out and the spring isn't all condensed, where it's just relaxed, okay? So it says the time it takes for the ball to move from its max displacement, so how far out it can go on the spring or how high up, the time that it takes above 0 to its max displacement below 0 and back is going to be 4 seconds. So that's going to be our period. Okay, so the time it takes to complete one revolution of our ball on our spring, that's going to be like our period, and then our max displacement would be our amplitude. Okay, so just from word problems, we can go ahead and write sine and cosine equations. So we haven't done word problems with that. Okay, so from our example on the last slide, our amplitude, I said, is our max displacement. So it told me that it's going to be 10 centimeters. Okay, so my amplitude for this example would be 10 centimeters because that's the distance that that ball moves. Okay, so on my graph, that's how high up or how high down or how far down it could go. Is everyone okay with that? Yeah. Yeah, and then the time it takes for it to complete its one going from rest, out, back, up, down. So it's the time it takes for it to complete its cycle. So to come down, back to the middle, up, back to the middle, it's going to be its period. So for the next question, the period would be the 4 seconds. Okay, so yeah, so we're just going from word problems to writing like sine and cosine equations from our word problems. Okay. So let's go ahead, so it's called simple harmonic motion. So our equations, they just like to change variables to change variables. But, so this W right here is the same thing as B, and the T just stands for time because we're talking about like the ball going up and down over time. But so our equations still look exactly like they did with sine and cosine. So it's A is our amplitude, sine of this W is just going to be that B value for what it takes, like the number you need for how long it's going to be for one period, that number that helps you figure out your period. And then the T is just X or theta or whatever you want. Okay? So they just changed up the variables. You don't have to change them. You can still write your equation the same way. And the D is just like a Y. Okay, so it's not a line of oscillation. We're not going to have line of oscillation with this because we're not going to like move up or down. It's not going to be shifted up or down at all. Okay, but so period would just be 2 pi over W or B. So if you're just checking your answers in the back, you might see it written as W. So that way you just know that W and B are the same thing.
Oh, so W is B and T is X?
Yeah, yep. And the only new thing is we'll talk about like frequency. So think about like radio waves, like they talk about like in the real world, like the frequency, different like electronics, like what wavelength, different stuff is running on. To solve for frequency, you just flip your period. So it was period was 2 pi over W or 2 pi over B. Well, frequency is gonna be W over 2 pi. So we'll need to know that little equation. Carter?
If they're the same thing divided, why don't they just, like, why is it just, BX?
I don't know, I don't make the rules, so.
Are we going back to that ball example, just like solve something?
I'm pretty sure.
No, we'll do more like, but that was just to like introduce where it comes from. Like, okay, so it says when the spring is at equilibrium, so when our D, so you can think of like where these come from, D is your distance, so that's why this is D now, so it's like the distance at like specific time. So when your distance is 0, when your time is 0, because if you think about this on a graph, D and T are X and Y, so if your D is 0, when your T is 0, so if your distance is 0, when your time is 0, you're gonna be at the origin, because you're not moved up or down at all. So if it tells you something like that, you know you're gonna be using our sine equation, because with sine, we start at the origin. If your spring is already stretched out, so like when your time is 0, your distance is up here at 2, your spring is stretched out, you would be using the cosine equation. Okay, so you're gonna have to figure out which equation you wanna use based off of the information that you're given. So if your distance, so if you're not displaced at all, if your ball is starting just at rest position at 0, you would use sine. But if your spring is stretched out, you have like your amplitude, so we'd be using cosine. Okay?
So with harmonic motion, is that gonna only be up and down? I don't know, you said something about radial wavelengths or something like that.
Yeah, so it's just gonna be like anything that could be modeled by this. So it could be, here's my ball on a spring, my ball's going up, and then it's going down, and then it's going up, and then it's going down, or like radio waves, or like just all, like lots of different, like the ocean, like follows this pattern, like the waves go out, and then they go back and out and back, like all sorts of stuff follows that.
Can you use that motion again?
No.
The waves?
So T is X,
Yep, but it's just for time, because now, so the
And so it's
reason they
also
changed
period?
them, what,
but it's also period then?
no, our period comes from the 2 pi over W or 2 pi over B, so you're not using T for that.
Didn't you?
B is our period.
Well, T equals, like in that one ball example, T equals 4 seconds, and you said the 4 seconds was our period.
Yeah, so it said the time that it took, so it said the time it took for the ball to go in and out and in and out, so, that was our
T is
period.
not period.
Yeah, T is not period. Okay, so T stands for time and D stands for distance, because these are all like real life examples now. Okay? So let's do some. Or we'll do it tomorrow.
Good idea.
Okay? Alright guys, we'll finish these up tomorrow.
We have a lot left.
We